All right, welcome to the Explainer. Today we're talking about something we're in every single second but can't even see. It's that invisible shield that makes all life on Earth possible, our atmosphere. It's this huge, super complex system, and you know what? We're going to break it all down.
So, what exactly is this life sustaining blanket? Well, it's basically this huge layer of gases that our plant's gravity holds onto. You can think of it like Earth's own personal suit of armor. It insulates us, it shields us from all sorts of nasty stuff from space, and oh, yeah, it gives us the very air we need to breathe. So, what is this invisible shield, and how in the world does it actually work? Okay, let's really get into it. We're about to take a journey, starting right here on the ground and going up layer by layer all the way to the very edge of space to figure out how this whole incredible system ticks. So here's the plan for our trip. We're going to start with the recipe for the very air we breathe. Then we'll hop on an imaginary elevator and ride up through all the different layers. After that, we'll see how it all works together like a giant climate control system. And we'll finish up with the 5 most important jobs the atmosphere does for us. Sound good? Let's go. All right, first stop, the air we breathe. It's easy to think of air as just, well, air, one single thing. But it's actually this really specific, super important recipe of different gases. And if you look at this, it's pretty obvious that 2 gases totally dominate the scene, right? Nitrogen and oxygen. I mean, they make up a massive 99% of the air we're breathing right now. It's so easy to just ignore that little 1% left over. But trust me, that tiny sliver is packed with some absolutely critical stuff. So why this particular recipe? Well, that nitrogen, it's kind of a buffer. It dilutes the oxygen so things don't just, burst into flame all the time. Oxygen, of course, is what we need to live. It's the fuel for our bodies. And that little 1%? That's where you find gases like carbon dioxide, which basically act like a planet-sized thermostat, keeping us from turning into a giant snowball.
Okay, time for that elevator ride to space. Imagine we're stepping in right now at ground level, and we're just going to head straight up. Each floor we stop at is a totally different layer of the atmosphere, with its own weird and wonderful properties.
First stop, the troposphere. This is our floor. This is where we live. It's home. Pretty much all the weather you've ever experienced, from a light breeze to a massive hurricane, it all happens right here. Why? Because this layer holds almost all of the water vapor, and you need that to make clouds and rain and storms.
All right, going up. Next stop, the stratosphere. Now, this layer has something incredibly important, the ozone layer. Think of it as Earth's natural sunscreen. It soaks up a ton of harmful UV radiation from the sun, and all that energy it absorbs actually makes this layer get warmer as you go up. It's also why commercial jets love flying here. It's a super smooth ride above all that crazy weather we just left behind.
Okay, heading up again, we're now in the mesosphere. And whoa, it gets cold here. This is actually the coldest part of our whole atmosphere. But it's also a major protective layer. This is where most meteors from space burn up, creating those amazing streaks of light we call shooting stars. So next time you see one, you can thank the mesosphere. And now we're entering the thermosphere, which is a place of total extremes. Get this, the temperature can skyrocket to thousands of degrees, but because the air is so incredibly thin, you'd actually feel freezing cold. It's wild. This is where the International Space Station orbits, and it's also where you get those absolutely spectacular light shows, the auroras, the northern and southern lights. And here we are, our final stop, the exosphere. This is it, the final frontier. This is where our atmosphere doesn't just come to a hard stop, it just sort of thins out and fades away into the emptiness of space. The air is so spread out up here that individual molecules can actually just escape Earth's gravity and float away forever. So let's do a quick recap of that elevator ride. We started down in the troposphere, where all the weather happens. Then we went up to the stratosphere, home of the ozone layer. Above that, the mesosphere acts as a meteor shield. Then you have the thermosphere with the beautiful auroras, and finally the exosphere, which just kind of fades out into space. See, every single layer has a super important job to do. Okay, so we've seen all these different layers, but how do they all work together? Because it's not just a stack of pancakes, right? It's one big, interconnected system that basically works like a global climate control for the entire planet. And just how much of a difference does it make? Well, it's pretty night and day. With our atmosphere, we've got a comfy average temperature of about 15 degrees Celsius. Without it, Earth would be a frozen rock. We'd have these insane temperature swings between day and night. Honestly, life as we know it would be completely impossible. So, what's the secret sauce here? It's something called the greenhouse effect. And this is a totally natural, totally essential process for life. You've got certain gases in the atmosphere that act like a cozy blanket, trapping just the right amount of the sun's heat to keep our planet from turning into a giant popsicle.
Okay, let's wrap this up by bringing it all home. We're going to look at the 5 key functions, the most important jobs our atmosphere does for us every single day.
When you really get down to it, it all boils down to 5 absolutely critical jobs. So here they are, the big 5. Number 1, it gives us air to breathe. Obvious, but crucial. 2, it's our shield against radiation and space rocks. 3, it regulates our temperature, keeping things just right. 4, it creates weather and the water cycle. And number 5, something you probably don't think about, it allows us to hear sound. Without air for sound waves to travel through, our world would be totally, eerily silent. So you can see our atmosphere is this incredibly complex, finely tuned system that's been built up over billions of years. It's the very thing that makes Earth a living, breathing planet. Which kind of leaves us with a big question, doesn't it? Knowing everything this invisible shield does for us, what's our responsibility to protect it?